Hello everyone, this is Sanjay. In today's video, we're going to study about trigonometry of class 10. In previous classes, we have studied about geometry, where it deals with circle, triangle, quadrilateral. So, now what does this trigonometry actually mean by? It is very simple. Let us look into the word. The word trigonometry is derived from Greek word. Okay, in order to understand better, let me split the word trigonometry into three parts: tri, gon, and metry. Tri means, hope you know that, is 3. Gon means sides. Metry is nothing but measurement. So by this we can easily say that trigonometry means measurement of 3 sides. Yes. Which is a geometrical figure we can find 3 sides? Yes, it is a triangle. Triangle is the only geometrical figure we can find 3 sides. Now, trigonometry is nothing but is the branch of mathematics dealing with the relations of sides and angles of a right triangle and with the relevant to functions of angles. I will come to this very shortly. As this, we can say trigonometry is basically dealing with right triangle. So considering all this, we can easily say that trigonometry is nothing but the measurement of 3 sides of right triangles. Right triangles, you hope you know that this was a right triangle with a 90 degree. Yes, it was a 90 degree. From this, you can easily say that trigonometry is nothing but measurement of 3 sides of right triangle. Here is Hipparchus. The first trigonometric table was compiled by Hipparchus, who is known as father of trigonometry. Now let us see, why do we need trigonometry? We may raise the question, instead of this trigonometry, we can use the geometry as we know well. See, geometry has its own limitations. Let me take an example, you can understand better. Example, A, B and C. The angle B measures 90 degree. The side AC measures 13 centimeter. Okay. By knowing the two values of this triangle, the angle B and the side AC, can we able to find the another two sides and another two angles of this triangle by using a geometry? No, we can't. So let me take another example. Let me name it as M, N and O. Angle O measures 30 degree and side MN measures 5 centimeter. Okay. Now by knowing these two values, can we able to find the another two sides of this triangle by using the geometry? No. So this is the example for limitations of geometry. Next, how this trigonometry? See, once you learn trigonometry, for an example, a triangle, there is a triangle ABC. The angle B measures 90 degree and side AC measures 8 centimeter. Knowing the value of one angle and one side of a triangle, we can easily find the another two sides of a triangle and another angles of a triangle. So basically this trigonometry is applied to right triangle, as I said in the beginning. Gradually it can be applied to tower, hill, river, tree, to know their height and width. Trigonometry is applied to many streams. For an example, if we apply trigonometry in physics, it will become engineering. For our higher mathematics to lower mathematics, it plays as a link. Next, in some of the cases, it has been given as trigonometric ratios. Let us see what do you mean by ratio first. Ratio is nothing but comparing of two quantities. Let me take an example. There's a two guys, Ram and Beam. If Ram had 5 laddus, Beam had 3 laddus, this is the way we are going to represent the ratio between Ram and Beam. See here, Ram is to Beam is equals to 5 is to 3, where Ram had 5 laddus and Beam had 3 laddus respectively. Here is another kind of representing a ratio, that is R by B equals to 5 by 3. In the same way, what do you mean by trigonometric ratios? Trigonometric ratio starts with right triangle as I said before. Here is the right triangle, triangle ABC, where angle B measures 90 degree. The side which is opposite to 90 degree is called hypotenuse. Hypotenuse. The hypo is nothing but biggest. Okay, a side which is opposite to biggest angle is called hypotenuse. Okay, now how can we say the angle B as biggest angle? It's the biggest angle because we know that angle A plus angle B plus angle C is equals to 180 degree. Okay, now we don't know the angle A, plus we know the angle B is 90 degree, plus angle C we don't know, 180. Then angle A plus angle C equals to 180 minus 90. So we get angle A plus angle C equals to 90 degree. See here, by adding these two angles we are getting 90 degree, which means angle A is lesser than 90 and angle C also is lesser than 90. Angle B is the biggest angle because the only angle making a 90 degree, whereas here by adding these two angles, angle A and angle C, it is making 90 degree, which means the hypotenuse means biggest side of a right triangle, which is opposite to 90 degree. We came to know that angle B measures 90, which is the biggest angle compared to A and C. Now, angle C may measure 30 degree, 40, 50, whatever we don't know. In mathematics, we denote unknown value in variables like x, y, and so on. But in trigonometry, we used to call it as theta, means some angle. See, here we don't know the angle C, so we denote it as angle theta. We don't know the angle. Now, the side which is opposite to theta, sorry, let me write it correctly. Yes, the side which is opposite to theta, we call it as opposite side. Okay, now the side which is next to theta is called as adjacent side. Okay, first thing we should understand how to identify these three sides of right triangle. So let me explain you once again. The side which is opposite to 90 degree of right triangle is called hypotenuse. Then the side which is exactly opposite to theta is called opposite side. Then the side which is next to theta is called as adjacent side. Now let us see in how many different ways we can compare these sides of triangles. Here is a triangle PQR. The side which is opposite to 90 degree is hypotenuse. The side which is opposite to theta is opposite, and next to it is adjacent. Now let us compare. The first comparison is PQ. See here, PQ by PR. PQ by PR. That is opposite by hypotenuse. Hypotenuse, which is named as sine theta. Next comparison is side QR by RP. QR by RP or PR. That is adjacent by hypotenuse. Adjacent by hypotenuse, which is named as cos theta. Next, side PQ divided by QR. That is PQ divided by QR, which is opposite by adjacent, which is named as tan theta. These are the three different trigonometric ratios that totally we can compare in 6 different ways, and it is very easy. It's just a reciprocal to this. See here, sine theta opposite by hypotenuse. So let me write it as reverse. That is hypotenuse by opposite. Hypotenuse by opposite. That is side PR divided by PQ. Then the side hypotenuse by adjacent. Hypotenuse by adjacent. That is the side RP or PR divided by QR. Next, the side QR divided by QP. That is adjacent divided by opposite. That is QR divided by PQ. These sides are named as cosecant theta and secant theta, then cot theta. So these are the 6 different ways we can compare the right triangle in a trigonometric ratios. Now, how to remember these 6 different ratios of trigonometry? It is very simple. If I ask you the question, when you don't know about trigonometry, your expression will be, oh, I don't know it. But once you learn about trigonometry, once you know everything about trigonometry, your expression will be, ah, I know it. Yes, only by remembering these two you can easily remember all the 6 different trigonometric ratios. Yes, it's very simple. We know that sine theta is nothing but opposite by hypotenuse. Yes, first one, opposite by hypotenuse is sine theta. Okay, that is sine theta. Next, cos theta is adjacent by hypotenuse. See here, adjacent by hypotenuse. This is cos theta. Now what about tan theta? Tan theta is very simple. See here, tan theta means opposite by adjacent. Okay? Opposite by adjacent. This is tan theta. So once you know these 3 ratios, you can easily write this also. It is just the reciprocal of this. Yes, this is the simplest way to remember all the 6 trigonometric ratios.